Welcome back everybody to my Advanced Programming Concepts using C++. This is your instructor Alex Louie. Today we're going to talk about overloading functions. Very important concept in the beginnings of object-oriented programming, but we're going to start it here in C++, and then you'll probably use it later on when we get to OOP. So let's take a look at an example, and then we can take it from there. Here's a short program that shows an example of an overloaded function. So if you notice, the function has these functions have the same name. They have the same number of data types, but the data types in the parameters are different data types. So this is an int, this is a double that's passed in. Now that is what we call an overloaded function. So when you overload a function, what the compiler does is it looks at the function signature. Again, that's the function signature. So what composes the function signature? The function signature uses the name of the function and the parameters in that function. Okay, so in this case, the return type is not looked at. The return type is not looked at. So when overloading functions, what's being looked at is the name of the function and the parameters in the function. That's what will distinguish if a function is overloaded. Okay, and in this case, the data type parameters are different. Okay, which indicates that this is an example of an overloaded function. Now, why would you want to do that? Well, there's many reasons. So sometimes you may want to write a function that either you want to accomplish two use cases. So in this case, let's say we want to write a function to square a number. And because we're squaring a number, we want to have the ability to be able to square an int and then also square a double. Now, that's almost a bad example because you can always pass in a double value as a as a whole number. But just for argument's sake and for simplicity's sake, I'm using that, right? Now, if we look at the definition down here, you'll see that I have an integer that's passed in, and then the definition is almost the same. So return number times number. Same thing with the overloaded version of square again. Here you have a double, and then you return number times number. Okay, so the use case here is you could have certain situations where you want to write a function with the same name, but you want to change the parameters of the function. Okay, the number of parameters of the function. So if you had different number of parameters here, that's also considered an overloaded function. Okay, overloaded function. So in this example, what we have is, if I run this program here, it's going to ask me for an integer and a floating point number. So I can enter 30 and then 12.5. Okay. And then I can call both square functions, the one that takes the int and the one that takes the double, and that should get the work done. So 900 and 156.25. Okay, so that basically is kind of the whole gist of an overloaded function, where you want to provide the developer or yourself the ability to use a function that pretty much does the same thing, but it has a type of polymorphic feel where you'll have different parameters that are passed into the function. Let me give you another example. All right, so let's take a look at another example where we want to calculate the salary or the weekly pay of an employee. Okay, so I have a couple functions here, but these are the ones that are overloaded. So you can just put a comment here, overloaded functions. As you see, they have the same signature, right? And then different number of parameters. Okay, so this one has 2 parameters, and this one has 1 parameter. So the compiler is going to look at the signature of the function and decide that this is an overloaded function based on the parameter numbers. Okay. So simple program. I'm going to ask the user what does he want to calculate? Does he want to calculate an hourly wage for a weekly payment or a salaried, right? In line 14, I'm just getting the user's choice. So if we look at the definition, I am going to take the letter that they type in, and as long as they type in an H or an S, then I will return that letter back to the main. Okay, if they don't, then this loop is going to keep them in there. All right, cool. Now once I have that choice, then I'll make a decision based using my switch case statement. If or case when there's an H, I will ask additional questions. I will say, well, how many hours were worked? Because when it's an H, when we have an hourly, we're gonna call the calc weekly pay with the two parameters. And if you see that overloaded function down here, that's going to multiply the hours times the pay rate. So for example, if they worked 40 hours a week, so 40 hours a week times their pay rate, which let's say it's $20, right? So that's about $800 a week, right? If it's an annual salary that they're typing in, that's a different case, and we'll take a look at that in a little bit. Okay, so we ask for the number of hours, what the hourly pay rate is, and then we call our function. Okay, we do an inline call on the cout, and that's perfectly fine. Okay, and preferably I actually like to assign this value to a resulting variable based on the return type, but in this case I'm just showing you an example, so it's perfectly fine. Then I will write out what the gross weekly pay is, where I grab whatever they typed in, which is the number of hours worked times the rate, and then just output it to the console. Okay, now I'm using the IOMNIP library, so I am going to set my fixed show point precision up here, so you should see it formatted nicely. Now if it's a salaried employee, I'm just going to ask for their annual salary, and then I'll divide that by 12. So that's what this version of calc weekly pay does. Calc weekly pay will divide the salary by the number of weeks in a year, which is my constant variable. I set it to 52.0. Okay, so let's run this through the whole thing, and then hopefully you understand. Okay, so do you want to calculate the weekly pay of H, an hourly employee, or S, a salaried employee? So if I type in H, okay, once I type in H, okay, this get choice is being executed, right? So it's waiting for input, just like here. And because it says that this H is not an invalid letter, it's going to return the letter back. Once I press enter, okay, my selection variable is going to have this H. And then I'm going to get additional questions, right? So I'm going to press enter. And then now I'm over here in this case. How many hours were worked? Okay, so I'll just put 40 hours, standard. And then we'll just put 15 hours, $15 per hour, right? So if I do that, then the gross weekly pay is calculated by my calc weekly pay overloaded function. Okay, now if you run this again, I can run the salaried one, and then now it's going to go into this salaried case. Okay, and now I can type in, let's say they make $40,000 a year. What is their weekly gross pay? So the weekly gross pay is $769.23 per week. Okay, so here's another example where you are using a overloaded function. Okay, and they do sort of the same thing because we're still calculating weekly pay, right? But there's two use cases here. You want to know when the user enters a salary, and then the other one is if they're an hourly employee, and so they need to enter the hours worked and the rate per hour. And this is another type of use case that you may want to use an overloaded function, because essentially they're doing the same thing. They're calculating weekly pay, except it's a different category. One employee is a salaried and the other employee is an hourly employee. Very good use case to do this, okay, to use an overloaded function. So when you use overloaded functions, you have to look at the use case. And if the use case makes sense, you don't want to go around and typing if statements inside your function, okay? Because I could easily have done this with one function, right? And doing an if statement in here. We want to try and get away from that, okay? We want to get away from if else, because it can get really messy, okay? So I think good practice is to use overloaded functions when it makes sense. But again, it's all up to the use case, and if it's going to get too messy, then you actually want to use a overloaded function versus just doing if else, if this. And then you also have additional parameters that you have to keep track of. That's something that you want to get away from. That's something that you want to get away from. I know you've perhaps in the past been taught that, oh, you can use an if statement. In the future, we actually want to acclimate ourselves to think in an object-oriented fashion, where you will get away from if statements and you'll start using something called interfaces. And with interfaces, you start to not, and try not to, you train yourself not to use if-else statements. So in this case, you could have used an if-else, but it's a more cleaner way to do an overloaded function. Okay, so that's it for me. I will see you on the next video. I hope you got a little bit of the concept of an overloaded function and the use cases to when you can apply it. I'll see you on the next video.